that, let's talk about some density. So today we're going to do things just a little bit different. So the last couple of days we did density equals mass divided by volume. Well, we gave you the mass, we gave you the volume. Well, today we're going to go a little bit further. You're going to have to figure out the volume of a cube. So we're going to refresh just a little bit before we worry about that. Okay, so first, what is density? Density is how tightly packed a substance's molecules are. And what is the formula for density? The formula for density is density equals mass divided by volume, or D equals M divided by V. So here's a really good visual of this. So on the left-hand side, you see a box that's the same size as the box on the right. Okay, so but the difference is the amount of atoms that are in there. So the one on the left is more dense, and we know that because there are a bunch of atoms all really close together in there. So more dense, has the same volume, but more mass, and the atoms are packed really tight together. The one on the right is less dense because there's way less atoms in there and they're spread further apart. So same volume, less dense. Atoms are not packed tightly together. Okay, so here we have three different cubes. So we've got cube A that has 1, 2, 3, 4, 5 atoms in there. They're pretty spread out. They're just kind of hanging out in there, right? So the cube that's B is the same volume. It's the same size as A, right? But if we look, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 atoms in there, and it's all the same size. So they're packed way more close together. And then we have C, who looks bigger. It's got more volume than A or B, and it has 1, 2, 3, 4, 5 atoms in it. So the question is, which of these cubes has the lowest density? Which one has a lower density than the others? So if we look at B, we've got the same volume. A and B have the same volume. A has less atoms in it than B, so A's volume is going to be less because they're not as tightly packed together. But then if we look at A and C, they have the same amount of atoms, but in C, they've got way more space to spread out. So C is going to have less less density than either A or B because they've got more room to spread out. The further apart those atoms are, the less dense they're going to be. Okay? So the next question is, which of those pictures shows a substance with greater density? So A and B had the same volume, right? So A has 5 atoms in that same volume. B has 10 atoms in that same volume, so they're way closer together, those atoms are, right? They're more tightly packed. So B is going to be the one with a higher density. Okay, so to calculate density, there's a couple of things we need to do. How do you calculate density? First, we need to find the mass of an object in grams, and grams are the basic metric unit of mass. So if we don't have it told to us in the problem, we could figure that out using a triple beam balance. Next, we need to find the volume of the object. So we're going to talk more about that in just a few minutes. And last, you're going to divide them. So density equals mass divided by volume. Okay, here's where the fun begins. So this is what we're going to be working on today. We need to find the volume of things before we can find the density of them. And we're going to be working with cubes today. So the volume is the amount of space matter occupies. There's two different units possible for these things. So let's see, if you look right here, the unit of measurement could be either a centimeter cubed or a milliliter. And if you think back to our vocabulary, that centimeter cubed is going to be of a solid. A centimeter cubed takes up the same amount of space as a milliliter, so here's your milliliter, but the milliliter is going to be liquid volume. The The centimeter would be a solid volume. So that's kind of the difference between those two. You won't have to know that like for the test or anything, but I thought that that might help clear some stuff up. So how to measure the volume of a square or a rectangular object, that formula is right here. Volume equals length times width times the height, okay? So we have the length right here. We've got the width right here. And here we have the height right there. So we'll give you those numbers when we need you to figure that out, and you'll just multiply them together. Okay, so here's an example of how to do that. So calculate the volume of this rectangular prism. And this should look familiar to you. So anytime you do this at home, you're going to set your problems up on your notebook paper exactly how we did for the density. So we've got volume equals length times width times height. So V equals L times W times H. And then they just plug the numbers in here. So you can see right here, our length is 4 centimeters. And they put 4 centimeters right there. Remember, our units are very important. This is science class, not math class. So make sure you put your units in there. Here's our width way over here, 4 centimeters. And they put that right there. And then we need to times it by our height. And here's our height over on this side, 6 centimeters. And there they put it right there. They entered that in a calculator. And here is the answer that they got. So 4 centimeters times 4 centimeters times 6 centimeters is 96 centimeters cubed. So that cube right there, that came up because we've got 1, we've got 2, we've got 3. That's a super easy way to think of, man, why does that cube thing happen? Well, you're timesing 3 things together. So we're going to put a 3 right there. How's that sound? Kind of easy, right? So units used for the volume of a rectangular prism is centimeters cubed. Centimeter times centimeter times centimeter equals centimeter cubed. Okay? So it's not too difficult. Y'all are going to be just fine, I promise.